Okay, we're going to look at the phase line and the stability of this equation. This is an equation I've just made up. It's a separable, autonomous, nonlinear ODE. Separable because we've got no, well, autonomous means it's separable, right? Autonomous means there's no function of t on the right-hand side. It's all functions of the dependent variable. And so naturally that's separable. It's non-linear because we've got a y squared. We're going to draw the phase line of this. So step 1, draw a line. Step 2, work out where the critical points of this equation is or are. So a critical point is dy dt equals 0. So that implies y minus 2, y plus 1 equals 0. That occurs at y equals 2 and y equals minus 1, right? I made this equation up. I chose nice factors. So at y equals minus 1, y equals 2. We just sketch them on. Now we've got to figure out what this equation actually looks like. Now, there's two ways we can do this. We can carefully look at the curvature and things like that, or we can stick in test points, right? I favor test points. They're really easy. This is a parabola. It's a quadratic equation, right? The right-hand side here is quadratic, so you know that it's a parabola. You know that the parabola passes through -1 and 2. The only thing we don't know about this parabola is whether it's a happy parabola, it's a sort of upward-facing parabola, or if it's a sad parabola, a downwards-facing parabola. So all we have to do is pick a test point, find out which side of the line that test point lies on, and we're done. At, oops, wrong color. At y equals 0, dy dt equals -2. So y equals 0 y equals 0, we're somewhere down here, right? The scale of our dy dt axis is completely irrelevant. Note that y equals 0 is not the turning point, right? That's not symmetric. The turning point will happen when y equals 1. Okay, so that's our plot of dy dt. And now we can draw in our arrows. So in this region here, dy dt is positive. In this region here, dy dt is also positive. However, in between the 2 points, y equals -1 and y equals 2, dy dt is negative. If it's negative, that means the arrows that we draw, our trajectories, move from the right to the left. That is, that they converge to y equals -1. Out here, they move from left to right, and out here, they move from left to right. And so we're left quite quickly with this nice phase line drawing, which I'm just going to reproduce down here in black. Just the line with the arrows. So no sort of extraneous information. We see that trajectories converge upon y equals -1, so that's a stable critical point, and they diverge from y equals 2, which is an unstable critical point.